So now we talk about voltage. Alright, voltage is dependence on the force equals to V square, potential difference between the thing, and then permittivity, area, 2D square is the the distance Right. So this has the advantage for very high R, very high resistance uh, in DC. So high R in this case is actually what? It's a distance between these two plates. Okay. So in order to have a high R means that if your distance is over here is this big, and if you square it, you're gonna have a damn big division across this one. So in order to ensure, because now it's only the battle between the voltage and the resistance, and I mean the distance, right? So they are in the same order. So in order to measure the amount of force, right, between there is movement or whatever thing, as long as you want it to be as higher force or lower force, what you're gonna do if you have a larger distance, you're gonna ensure that you have to input a very high voltage in order to compare with the resistance. So the resistance has to be damn high, okay, damn high, and then the voltage has to be also damn high. Okay, so if the voltage is damn high, what you're gonna do is actually to introduce um, v square over, anyway it will be like v square I, okay, equals to power. So if your voltage is damn high, you're gonna input a hell lot of power. If this is damn high, you're gonna have a lot of power, meaning you're gonna spend a lot of money in there, right? Which is not very good. Nonetheless, what's good is actually if you have a high resistance, if you input a high voltage, you would have a relatively good amount of value for force in newtons, right? Why I say so? It's because the area affects the system, the emissivity also affects the system. So if you want a very clear cut difference uh, across the force, that a way that the area and the emissivity is not in the picture anymore. Okay, your voltage has to be damn high, your distance has to be damn big, so that you can actually calculate the force across certain things. I don't know what the force is like. So yeah, so this is the thing. But the problem is that it's very expensive if you want to have a very high voltage. So the next situation is that you're going to implement this one, this cheaper one. So you connect a emitter over here. So a emitter is the full scale. This Fs means full scale. It's 1 milliamp. Okay, as we said earlier. So in other words, at this point, it's actually 1 milliamp. Okay, so if you want to measure a 0.1 volt, right? If you pass a voltage over here of 0.1 volt, since you know that I is equals to V over R, or V equals to IR, so you will just bring this R downwards, right? So V divided by R is equals to I. So in this case, you know your voltage is actually 0.1 volt. If you divide it by the 500 ohms, you will get 0.0002 ampere, which is 0.2 milliampere. Okay, so you can actually measure. Okay, this is 0.2 milliampere. With this, then from there you can calculate your voltage. Okay. However, one problem is that if your voltage is damn high, okay, because in this case we give you the voltage, right? So if you have something pass through, and then if the scale shows you 0.2 milliamp, and then you know your emitter resistance, then you can calculate your voltage. So in this case, if your voltage input is damn high, you're gonna spoil the whole system, right? Because 10 volt divided by 500 ohms is actually 20 milliamp, which is way off the scale, which is like that 20 milliamp. It cannot be, right? Yeah. So so this is not a very good implementation. So in order to do that, what they actually do is actually to implement a R multiplier over here. So what does it do? So what this R multiplier do is actually to increase the resistance, right? So if you have a resistance of 500 ohm, the R total in series is 500 ohm plus 500 ohm is 1k ohm. Okay, so using V equals to IR, okay, 1 milliamp times, this is current, right, times 1000 ohm, you will have times 10 to the negative 3, right? You will know that this is 10 to the power 3 times 10 to the negative 3, you only have 1 volt. So you have a 1 volt over here. So as your voltage, now this is the trend, right? This is the trend. Previously was the ampere, right? If you were to varies. So in that case that, yeah, anyway, what the hell am I doing? Okay, so in this case, if your voltage increases, you're gonna have more resistance in the multiplier. Okay, you're gonna have more resistance in the multiplier. So you're gonna vary the resistance over here in order to ensure that you can measure the voltage. Okay, 1 milliamp. So if you were to have this thing more level of resistors, your machine will be more expensive lah. But nonetheless, you can actually measure more sensitive, like 1 milliamp over here in this case. So once you see that it's 1 milliamp, you know that okay, uh this is some level of voltage. You get what I mean? Like how do I say? Because you know the overall R total, okay, and then you know that the full scale shows 1 milliamp. In this case, if let's say you input the voltage, okay, and then the full scale shows 1 milliamp, meaning at the very end of the scale, let's say this is the scale and very end is 1 milliamp. So V equals to IR, you know your resistance value, you know your current, then you can find your voltage, and then you know your voltage. So this is how the voltmeter works, how you find your voltage. And then if you were to have this concept already, how you want to build a voltmeter, you can actually build a series of resistors, right? So these resistors each itself carries few values of ohm, 900k ohm, 90k ohm, whatever. Okay, so with this, you can actually set the range 1000 volt, 100 volt, 10 volt, and 1 volt. So if you input your voltage, in this case, maybe you input 2 volts, then it goes, and then at here, um, V equals to IR in this case, right? So if the voltage, okay, pardon me, I think your voltage is going to supply through here, okay? And then either way, you're gonna go here, you're gonna go here, or you're gonna go here, or you're gonna go here. Okay, if the voltage goes here, let me see, tricky. So the voltage comes in into here, and then it will go through this resistor. Okay, V equals to IR. So now the resistors. So because you want to display in terms of current, right? In terms of this one. So if your resistance increase, so if your voltage, how do I say? If your voltage is constant, let's say 1 volt, and your resistance varies across this one, you have a varying amount of current. Maybe this is smaller because yeah, why am I talking? Be safe lah, okay, to be safe. The voltage is over here. You connect to here, connect to here, connect to here, connect to here. Okay, there will be a sensor. There will be a sensor over here to to some extent know that how much voltage you would want. Okay, based on these connections. So for example, if you fit in a 10 if you fit in a 5 volt, okay, this sensors will know that okay, your thing is between 10 volt and 1 volt. Okay, so you're gonna go through the 10 volt first, or maybe the 1 volt, and then you go through the resistors, and then you can calculate the amount of ampere. Okay, so whatever thing that reflects will shows this one. So there will be a sensor over here in the sense, but they actually didn't say anything about it. So this is why I have a bit trouble. But nonetheless, this is the concept of a voltage voltmeter, right? It's still using ammeter as a range. If you remember, it implements the same system, the needle system, magnet and magnet. It's not, yeah. So, but however, this is how the voltage is being connected. All right. So and then what is the problem again? Okay, now you'll talk about the voltmeter has to have a resistance of infinity ohm. Why? Is because let's say before measurement you have 500 ohm and 500 ohm over here, right? If you remember, if you want to connect a voltmeter, you have to connect in parallel with the resistors, right? So if you connect in that manner, what you measure is actually measuring 333 ohm, right? Where does the other ohms go? The other ohms actually go to the resistors of the voltmeter itself. So this is the voltmeter resistance. So more of the voltage will go to the voltmeter, right? So in order, so causing the the measurement to to have a different calculation, right? So imagine we have a 1 volt. Okay, we have a 1 volt passing through here, right? If you remember, the voltage divider rule says that if it's the resistance, right, 500 ohm, 1 divided by 500 plus 1 over 1000, and then you have the overall how many resistors. Sorry, my fault. The calculation should be this when you, so it'll be like 1000 plus 1 over 1000. So because denominator you have to make them same first. So it'll be like 3 over 1000, right, which is 0.003 equals to 1 over R total. So in this case you have to 1 divided by 0.003, you have 333.33 ohm. Okay, so because of this thing, the whole what you are measuring is actually measuring this dude as 333.33 ohm. So so this is why you have this thing over here. And the reason why you want to connect in series for the voltmeter is because if you remember, in parallel voltage are the same. Okay, voltage are the same in parallel. And then why you want to connect ammeter in series? Because ammeter are the same in series. I mean the current are the same in series. So these are all the concepts. Yeah. And then right. So next video we'll talk about measuring resistance and then multimeter. So I'll see you there.